So good morning, everyone. Thank you for making it at 9 a.m. on the Friday. So I'm happy to see quite as much of you. I'm Tom. I'm from Belgium, as some of you have noticed by now by the cookies I've been handing out. If you didn't get cookies yet, there's still some left after this talk, so relax. And, you know, I am a big fan of my cat. And I kind of miss him, because when I'm at conferences, I don't get to see my cat all that often. Now, I tried to bring my cat, but he didn't, he wasn't that cooperative to come all the way to London. Now, are there any other people who miss their cat who are really cat fans? It's a room full of dog lovers, or what? No, I just joke. But you have to admit that when it comes to the internet, that cats have been embraced as like the de facto feel-good thing. You know, cat pictures really are a thing that we look at, we search, and think, oh yeah, that's funny. And now, with GenAI, we can have as many cat pictures as we want. Hey, you want a cat sitting on a crocodile while playing a banjo? Yeah, boom. Doesn't make sense, but somehow it works. A cat performing a comedy show in front of a bunch of impressed goldfish, boom. Although, if you can see closely, the one on the bottom doesn't really look all that impressed, so it's not perfect. And honestly, if I had succeeded to bring my cat here, then I could have just sat down, like here, and I could have just gone like, oh yeah, there we go. See? But unfortunately, you're going to have to do this presentation with me, not with my cat. So I wanted to start with this because I think that GenAI is absolutely awesome. It has given us a bunch of stuff, endless cat pictures, but also things that have made our lives much easier, like composing emails and so on. The problem that I've been seeing is that currently people, especially on LinkedIn, these hype people have been saying, oh, it's the solution for everything. And I think, yeah, maybe not. But the problem is when there's such a big hype going on, and you dare to question the hype, people start bombarding you with like, yeah, but what about RAG, right? It's only, RAG will definitely improve these LLMs, but you can fine-tune these models. There's going to be agents. There's probably a bunch of talks about agents at the conference as well, and it will only get better. So it's hard sometimes to go against the hype and say, actually, no, we don't need or want LLMs for this. And that's something I want to talk to you about today. So I wanted to talk to you about something that LLMs can't do. And that's probably the opposite of what you've been hearing the last couple of days. Lots of talks about what LLMs can do. So I decided it's a nice Friday morning. We're going to do the opposite. And the thing that I'm mostly interested in is, can LLMs solve planning problems? Now, planning problems are actually problems that are everywhere. For example, this is a planning problem. You think about something like DHL or FedEx. They get 200,000 packages. They have 20,000 vehicles. How do you plan it in such a way that all these packages get delivered, while at the same time reducing the amount of CO2 emissions and cars that are actually needed to drive all these packages around? So that's a planning problem. Is that a question, or? Okay. When it comes to airports, there's actually a bunch of planning problems. These airplanes, they need maintenance, and there's quite some strict regulations on when these maintenance need to happen. Besides that, there's aircrew scheduling. Because if you think that scheduling like employees is difficult, for an airline crew, they usually have a home base. And when they take a flight to New York, often they would like that at some point they can come back from New York to the place where they actually live, right? So that needs to be scheduled as well. These are complex scheduling problems. And my neighbor is actually someone who plants doctors and nurses in a big hospital. And I was talking to my neighbor like, well, look at all these LLMs, look, ChatGPT, I can do all this cool stuff. And she said, yeah, but I have to struggle with this. So, and this is a very simple schedule with only 3 people, but it shows kind of a bit of the complexity that goes into planning these things. You have different sorts of shifts, and as you can see, different employees have different skills. Like Anne can work in an emergency room or intensive care, and some of these shifts require that you have the appropriate skill, right? So Anne can actually do the late shift because that one requires an emergency room. And my neighbor asked me, like, how can an LLM solve this? Like, we have 7 days, we have 5 shifts per employees, we have 30 employees, so that's 150 things that we need to assign. And there's about five constraints. And the constraints really are, what kind of employee can I assign to a shift? If an employee doesn't have the right skills, you probably shouldn't assign them to that shift. For example, if you need heart surgery, you don't want someone that's a nurse to be assigned to that. I would like a cardiologist to be assigned to that shift. There's also time between shifts, and there's a bunch of stuff like that. So she asked me, can an LLM solve these kind of planning problems? And I tried very early on with basic ChatGPT, and of course that didn't work because it's just generating the next token. But these reasoning models that have come out recently that can actually reason about a problem, that sounded interesting. So I decided to try it once again. And I actually thought at some point that it would be a walk in the park for LLMs. So I'm going to show you kind of what happened during those experiments. And I can't show you a full live demo because in even a simple example, the reasoning took 12 minutes. I think that would be quite a bit boring demo. I know I have cookies and such, but that's not enough to entertain you. So I'll show you, kind of walk you through some interesting periods in that reasoning. So first off, a lot of Python. So while it may seem that these LLMs are doing smart things, they often delegate things to Python to analyze the data itself. And to its credit, it did actually find in the data I was using, it did find the 3 shifts per skill daily across 5 days. So it did extract the data quite well. And it even, in human terms, started saying like, oh, Dan can't work on Thursday or Friday due to unavailability. So he's not available. So it was actually extracting the data quite well. It also started telling me a bit more about the schedule, like, hey, I noticed shifts for ambulance, ORL, and surgery, so that those are the 3 skills that you'll see coming back. I'll explore some more shifts and get the complete schedule. So it actually found the skill requirement for certain shifts. Good. Then it went a bit off the rails, confronting Hugo's multi-skill use, ensuring Orlando and surgery shifts are balanced. Orlando? Oh yeah. One of the skills is ORL, which also happens to be the Orlando airport code. So that went a little bit off the rails, but it's okay, it's okay. It recovered somewhat in the end. Then it started saying, to manage rule 6. What's the problem with that, if you've been paying attention? I only had 5 constraints. What is rule 6? So I give it a schedule. I say, keep these 5 rules into account, and suddenly rule 6. Huh? What? And I was looking at it, and actually it says, yeah, to ensure shifts, avoiding a night to day shift. So if you have a night shift, that you don't immediately afterwards have a day shift. I didn't add that rule myself, but it invented it. And it's actually a pretty good rule. I didn't ask for it, but it added it. But it's like, if I don't ask for it, do I want the computer to do something? Kind of creepy. In the end, I must say, it actually generated a schedule. So it did succeed in making a simple schedule for like one day or 2 days. But 1 or 2 day schedule is easy. I mean, relatively easy. You could probably do that on paper. So then why would you need such a, why would you let ChatGPT do it automatically? So what is a realistic schedule? That doesn't work anymore. So once you scale to things that are actually realistic, like 3 weeks and 20 employees, I ran into a lot of issues. One of them is unable to display this message due to error. I don't know why, because I couldn't access like a debug mode or something. So all I could see is it's not working. I assume it's going to be something context window related, but it just didn't work. The other thing is that sometimes when you ask it something, it will do weird things that no human would do. When you ask it, could you generate me a schedule? I called it the trust me bro answer. It's basically, it gives you a bunch of shifts, and then somewhere halfway it says, the output continues for all shifts, blah, 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 but it's commented. Like, it can't actually spew out the entire schedule, so it just says, trust me, I did it. And whatever I tried, I could not get the full answer out of it. This is not how humans would ever try to approach this. Anyway, in the end, I got for 150 shifts, it said, oh, I obeyed all the constraints. And I thought, wow, okay, cool. So we can finally use LLMs to do this, to do these complex scheduling problems. But that was slightly over-optimistic. And when I say slightly, I took the output of that scheduling thing that I gave to the LLM. And when it's JSON, you don't really see the problem. But when you start visualizing this, you see there's a few problems with the schedule. So for those in the back that can't, for which it's maybe a bit too small, so the red areas, like this one, actually means that that person is unavailable, but they got assigned 2 shifts. And not only that, they got assigned 2 shifts at the same time. And everywhere where you see this red button, it's actually where the person doesn't have the right skills for this shift. In this case, Amy King is a doctor, but this shift requires a cardiologist. Now, you could imagine how that might go wrong, right? So it doesn't actually work, even though it says that it works. So why do LLMs fail here? And I think this is like an essential lesson I want to give you today. Whenever an LLM is unable to do something, I think it's very valuable to try to figure out why it's failing at that. Not only because, in a way, job security, because if LLMs can't do that, then that's something that we can solve in a different way. But also just purely out of interest. What are the hurdles here that are stopping these LLMs from doing that? And I think when it comes to solving these sorts of scheduling problems, it's that scheduling and making these sort of schedules is not a sequence of decisions. And let me explain that with the previous example as well. So we're going to do a small exercise. We're going to schedule these 3 shifts to these 3 people. So how would you typically approach that? You would start just with the first one, right? Early shift. We look, early shift needs intensive care. OK, Anne has intensive care, so we assign it to her. Second one, we take the day shift. Needs oncology. Beth has oncology, so we're going to assign it to Beth. And then finally, we have the late shift, which means that we are going to assign it to, oh, wait. And then you're stuck. Now, you could have said, yeah, but Tom, you could have foreseen this. Because if you had looked a bit more ahead at like the late shift before you assign anything else, then you would have known that this doesn't work and that you have to flip them around. But how far can you take that idea of having to look at the entire list of skills? Let me do you one more. Next day, the early shift needs oncology. So if you continue like this, you assign it to the only 2 people that have the oncology skill, Beth and Carl. But then you have an issue because there's not enough time between these shifts. People need to sleep. Now, how do you solve that? Is by changing your entire schedule and start from the beginning. So this is why these sort of scheduling problems are difficult, because one little extra element can make sure that you actually have to change your entire schedule to obey all the constraints that you have. And that just doesn't work. Now, you could think with reasoning models that the LLMs could reason through this. Or we could even brute force through it with some code and just do all the things. OK, then let's do a small exercise again. 30 employees with 150 assignments. How many different combinations could I make? Well, let's say we have 1 shift. Then you have 30 different options, because you have 30 different employees that you can assign to that 1 shift. Ignoring constraints for a second. OK, if you have 2 shifts, then you have 30 times 30 options. Because the 2 shifts don't have to be at the same time, so it's possible to assign the same person, well, theoretically possible to assign the same person to the 2 shifts. 3 shifts, you get 3 to the power of 3, 30 to the power of 3, and I think you can see a pattern by now, which means that if you have to assign 150 shifts, you get this number, 30 to the power 150. Now, that doesn't, it's such a weird, we don't see these numbers all that often, so it's difficult to conceptualize how large is this actually. So let me put it to the power of 10. So that's 10 to the power of 221. Still, that doesn't mean much. So I have to give you some sort of analogy. So let's talk about atoms in the universe. Atoms in the observable universe, there's about 10 to the power of 80. So the number I just gave you, assigning 30 employees to 150 shifts, has 141 more zeros behind it than all the atoms in the observable universe. So if you think about brute forcing this, I used to have a graph in the presentation that shows you like how long it would take to brute force through this. I think about halfway we're at the end of the universe. Our sun has exploded and nothing exists anymore. So you need to realize a good schedule is worthless if it takes calculating until our sun explodes, basically, to have it. So that doesn't work. We can't brute force it. And LLMs kind of have the same problem. You can't optimize for such a search space by predicting the next token or trying to reason through it like a human. And that's also why these problems are difficult for humans to do. As you saw, adding a few more shifts and suddenly you have to change your other shifts because else the constraints don't work anymore. So LLMs can't optimize schedules. That's basically what it is. But AI can, and this is one of my major gripes recently, because when we're talking about AI in the public sphere, we don't mean AI, we mean this, we mean GenAI. GenAI has kind of co-opted the entire AI name, but it's actually only a small part of what AI is as a whole industry, or a whole sector. Because not that long ago, machine learning was the AI, right? Then that was the real hype thing. And honestly, I love machine learning. Because machine learning, you could finally give some data to a computer and say, you figure out what this means, and we'll see later what happens. I really think it's awesome because one of the things that I like is how much it has enabled for us. For example, I don't know if you recognize this. Sign language. And thanks to machine learning, and if you have enough of this data, you can actually train a machine learning model to live translate. I was trying to do it, but I actually can't do it. To live translate hand gestures to language. So if you don't speak sign language, then you can still communicate with someone. But then, can machine learning be used to optimize these schedules then? Because I said that AI could. And actually, no. Because if you think how schedules work, or our machine learning works, let's start there. It needs to learn from data. But the question with scheduling is, what data? Where are you going to find enough data to, with machine learning, predict exactly the schedule? So not how many employees you need, but exactly the schedule. You don't, because one day someone is sick, the next day someone has a holiday, then it's other reasons. So there is not enough consistent data to generate a schedule. And as you've seen, like one small thing can change your entire schedule. Machine learning is only accurate, like at best 98% of the time. So those 2% can actually make sure that you have to change everything anyway. So that doesn't work. And as I've shown you, scheduling is actually a set of interlinked decisions. It's like a Rubik's Cube, but a very complex one. And you know, if you've played with the Rubik's Cube before, you have one side that's completely finished, and you think, oh, I'm almost there. I just need to change this one thing here. And you start switching, and suddenly your entire Rubik's Cube is messed up again. So it is a very difficult problem to solve. But luckily, machine learning isn't everything in the AI cycle. There's more to AI than even machine learning. But we've kind of forgotten about that because there's this thing called the AI effect. And it basically states that whenever we understand something in AI, we stop calling it AI. And that's kind of what has happened with a lot of very valuable technology as well. For example, one of the technologies I'm going to show you in a bit has to do with mathematical optimization. And that's really finding the ideal inputs and trying to maximize like a cost function. Now, mathematical optimization has one downside. It has the word math in it. And some people react to math like this. It's a bit scary, right? It's a language we don't see that often. Most of us probably don't see that often. So it's a bit scary. But it actually doesn't have to be. And that's what I'm going to spend the rest of my talk talking about. And that's something that we've dubbed planning AI. But it's actually something that you can do perfectly well in Java. And that's using something like Timefold Solver. So Timefold Solver is an open source framework that actually does all these planning optimizations for you. And it does it, all this difficult math, scary math, it does it in domain code. So you write Java domain clauses like you would do for anything else, and you annotate it. So think a bit like the people that know JPA to connect to databases. It will look very similar to that. You have domain classes, you annotate it, and then the magic happens behind the scenes. It's open source, Apache license, so you can do with it what you want. And it's available in Java, Kotlin, and Python, although a small side note, because I know AI is often like Python heaven, right? Everything's done in Python. We noticed that, excuse me, we noticed that for us, the Python was too slow, so our Python is actually a wrapper around our Java code, like a very thin wrapper. And that was actually way faster than doing it in Python. So we'll see what happens in the near future when new features in the JDK come with Babylon and Leiden and all that fancy stuff. But I think Java is in a very good space to do some more AI work. So let me just show you what that looks like. So I'm going to jump to a demo. Now, what you should know about Timefold is it does not come with with a UI. We have made like a very fundamental UI just for demo purposes. And here you see 133 unassigned shifts. I can go to the by employee section so you can kind of see that employees have times when they are unavailable, so they really can't work, and sometimes they actually want to work. Like my partner is off skiing and I have nothing else to do, so please just assign me a shift so I have another day off. And the cool thing is now that if I click the solve button, that Timefold will try to fill in all the shifts. And that's going to happen now. And you see, it works perfectly. I've only forgotten one thing, and for that, we have to go into the code. So Timefold, as I promised, that's a bit small, right? So I'm going to go full screen here. As I promised you domain classes. So here you can see, in this example, we're assigning employees to shifts. So I have an employee class. I'll make that even a bit bigger. Is it visible in the back? Readable? OK. So we have an employee class, nothing too special about it. Employee has a name, some skills, and then unavailable, undesired, and desired dates. And then we have a shift. And the shift is annotated with planning entity, which sounds familiar with JPA, right? I promise you it would kind of look like that. Start time, end time, a location, the required skill for that shift, and then this add planning variable. And what Timefold will do is it will take all the employees that have been configured, all the shifts that have been configured, and it will change that variable pretty rapidly, and it will try to find the best solution. Now, if you looked at what I've done here, you can see that there's one big glaring thing missing. According to Timefold now, as it's configured, this is the best solution because it has assigned everything. So it's done. Now, if your name is Elsa Green, you might not like this schedule. So we should probably add some more constraints in here. So even explaining to the algorithm, like there's some things you shouldn't do, is Java code. And now, I must be honest, it looks a bit creepy when you see it the first time. At least that was my feeling. You can define these constraints in Java code. So what that says, and let me put it a little bit higher. For example, we have a required skill constraint. And what this does is, for each shift, filter all the shifts, get employee, get skill. So get the assigned employee and that person's skill, and check if the shift required skill contains that one. If that is not the case, then penalize it. So say to the algorithm, this is bad. No, 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 don't do this. Now, if we start activating this one, because I commented this one, and I go back to here, and I run the solver again now, you should see that the result is quite a bit better. So now, the schedule, it's still not good, so clearly we're missing more constraints. But you can see that it's already taking the skills into account. So if it's a cardiology or nursing skill, then an ELSA can do it, and else if it's a doctor and anesthetic, then other ELSA can do it. That's an unfortunate random naming. So let's have a look back here. So there's a bunch more constraints we can add. For example, I only want one shift a day. Seems reasonable to only want one shift a day. No overlapping shifts, at least 10 hours between shifts. And if an employee is unavailable, they shouldn't work. So I've enabled them. Let's just solve this again. There we go. Oh. And now this thing that a human planner would take quite a while to get this, such a schedule done, gets done in a couple of seconds on this scale. Now, if you look at this can be better, right? There's a few things that we might tweak a bit. Anyone have any ideas? So you can see that both ELSAs are in the undesired, have a skill that's during their undesired time, and also here, down here, also undesired. So normally, making this schedule without taking that into account is where human planners sometimes stop. because it's already so difficult to make the schedule that taking desired or undesired into account is like, no, this is too much work already. But when you have an automated solution like this, then it's actually just a matter of adding more constraints. So I have undesired, desired, and we even have a constraint that's called balancing, which means it will take into account how many people are scheduled in weekends, and then it will fairly try to balance it to make sure that the weekend shifts are nicely divided. So let me show you what that looks like. Let me run it again. There we go. It takes a bit longer now, because this is such a bigger ask that it takes a bit longer to come to this solution. But that's okay. As you can see now, it took a little bit longer, but now you can see that it's actually taking into account the desireds even. So we have a few desired skills. And sometimes it's kind of hard to see just based on the schedule, is this better or worse? So we have this question mark here, and that actually calls the score analysis part of Timefold, where you can see in detail, and let me see, can I zoom in a little bit? Yeah. So you can see for all the enabled constraints, how many times they were broken, and if they were broken, to what extent, and so on. So we have detailed information. You can get detailed information for each of these to see, and these are business constraints, right? You can talk to your business owner about this. You made a plan, and you say, oh yeah, the algorithm thought this was the best plan. We have 7 desired dates for an employee. And if they say, no, I want something else to be more important, then they can change the weight. Let me just show you how that looks like. So here, so here, with the overlapping shifts, you can penalize like single items, like one hard score, but you can also penalize for each minute there is overlap. So you can scale the scoring as well. And of course, these constraints can get pretty complex. And I know it's a bit of a weird mix between the Java Streams API and something that looks a little bit like SQL. Like for each, you select something, you filter, and then you make a change. Trust me, once you get a little bit used to this, this actually reads quite well. But I said earlier, like, wow, these small schedules, that's relatively easy. So let's do something a bit more difficult. Let's do about 1,000 shifts. 1,000 shifts, that is, let me zoom out a bit. So that's these. Oh, that's this. So that's what we're going to schedule, and I'm just going to let it go. So that's with the same constraints I listed before. And that actually allows me to tell you a little bit something about Timefold. So while it's running, you can see here that there's some hard constraints being broken. So that's the really things like unavailability that you don't want to break. You can see the score here. So in this case, someone is missing the required skill. So that's not good, but it will probably get out of there. And if we wait a little bit longer, normally... So what I should mention about this sort of technology, oh, it got out of there, you see? So now it's 0 hard constraints, so this schedule is perfectly fine, obeying all the constraints. What I should tell you about this sort of technology is that it's actually, despite being AI, it's deterministic. I don't have to fear for this demo because I know exactly that it will always find this result. The only things that might not make it deterministic are things like there's something else on my PC running, so it's getting less CPU cycles. But that's kind of about it. Now, how does it come that Timefold is able to solve this? It actually does 2 things. The first thing it does, it just basically, if you have a puzzle box, it takes all the puzzle pieces and throws them on the floor, and that's an initial solution. The initial solution isn't good, but it's at least some sort of a solution. And then it starts moving things around. Now, you can actually see that if you run the code. So I should be able to show you back here. That's a little bit hard to read, but you can see that it is moving things around at a speed of 22,000 per second. So every second, it is moving around 22,000 of these shifts to see if it can find a better solution. So first, an initial simple solution, then it starts moving things around. And what it is, oh, I messed up here. What it is moving around is basically just this assignment, right? This, oh, this. It keeps changing these variables, and that's it. Let's go back here. Any questions so far, by the way? Yes, go ahead. Okay, so to repeat the question, how does it deal with last-minute changes? It's not something I have at hand right now, but you have the possibility to just replan. So if I click the solve button now, and I've changed one of the things, and it will actually start from there again and does the optimization again. Now, if there's some things that you want to fix, for example, an employee, let's say that this employee really wants to do this shift for some reason. Then you can, there's a mechanism called pinning, and then the solver will not touch that. That assignment will stay, and it will try to optimize everything around it. And that's kind of how we deal with showing this to human planners, because a lot of human planners go, I do not want this. Because I've been doing this manually, I do not want this. So to onboard them gradually and take them over into like how Timefold can help you is, we allow them to plan completely manually. We pin them, we score, and then we score the solution. So even if you plan something completely manually, this endpoint you can call anyway. You could use this. So then you can see as a human planner, what is my score? And then gradually, we advise that they remove the pins, so that then maybe 50% of the shifts are scheduled by Timefold, and they schedule the other 50%. And then slowly but surely do this switch. Yeah, next question. How do they work together with the machine?
Let's say the two people call in sick tomorrow. Yeah. You don't want all your schedule as an employee to change for the next 2 weeks because you want to be able to plan yourself.
Yeah.
You get what I'm drifting at?
Yeah. So you're basically asking, how do I'll repeat the question just to check that I understand you correctly. So if something happens, like an employee gets sick, you want to minimize the amount of change to the other schedule. Yeah. So you don't want to, because I showed you before, if you add one shift, it could be that your entire schedule changes, but you don't want that when it's in the next couple of days. So there's a few strategies for that. Either you use the pinning mechanism I mentioned, and you pin all the shifts for the next 5 days. You say nothing can change in the next 5 days. That's not always possible, especially if you want to replace that person. So in that case, what you would do is you would keep a field saying this was the originally assigned person. Then you have the planning variable that will change for the new assigned person, and you make a constraint that checks those two. And then you say to the solver, each time you've moved someone from the original schedule to the new schedule, you penalize it a little bit. And then the solver is incentivized to move as little as possible. So that's kind of how you, two approaches how you would solve that. Does that answer the question? Okay, great. Any other questions before I continue? Yes, down there.
Would the solver go through all possible scenarios before it decides the one with the best score? Or would it stop when the score is good enough?
So there's a couple different termination configurations in there. So triggers that make it stop. The most common one we see is the diminishing returns termination, which means that it looks at the score, and as long as the score is improving, it keeps running. But when it's starting to show diminishing returns, which you can configure, like if it's only going down like 0.5%, then the solver will stop. We also have time-based. Some companies say, you know what, we only have an hour to plan this for whatever reason, because in the next 2 hours we need to execute this. Then you can say to the solver, only run for an hour, and the best thing you can find in that hour, fine. When you ask me, does it try all possible solutions? No, because it can't. Because then you get to the end of the universe, basically. Our sun will explode. So that's why this approach of just throwing all the pieces on the table, using it's called a construction heuristic, to quickly construct the initial schedule and then moving things around, is one of the best approaches that we have found so far to solve these kind of things. Yeah, next question.
When it starts moving things around, does it purposely pick the worst scoring time, or is it random?
So the question was, if it starts moving things around, does it do it randomly or does it do it purposefully? there's actually a bunch of different algorithms behind the scenes that can tweak that. So usually we have, it does take into account the score that will change when it picks one. So for example, it will not move something if it will break a hard constraint. Because, and actually these moves, the things moving around, is actually configurable. So you can configure yourself how you want things to move. For example, there's an example of a delivery company in the Netherlands that wrote their own custom move for Timefold. Basically, when they assign items to baskets for the warehouse, items to baskets, they have a check in there that if the same item, like let's say this bottle of water, if I'm going to move this bottle of water and this bottle of water, and I'm going to switch them from basket, don't do that move. Because why would you do that move? Because it's technically like the same bottle of water in the basket. So there's ways to configure that. That's the long-winded answer. It will do it in a smart way, and it takes the score into account. So it's not just nilly-willy changing things around. There, if you go to our documentation, you can actually see all the algorithms that are happening underneath as well. Next question? I think you were slightly before. Could you wait for the microphone, maybe?
Can you maybe show? I'm interested in the constraint that balances things out. Like how does that look like in code? Because you showed that you write the constraint yourself about balancing, like so that the different employees are like spread out a bit. How does that work in the code?
So we actually have. So because we have these constraint streams, which is kind of a syntax that we defined ourselves, we do have. Let me go for the balance one. We basically have a group by load balance. So the balancing is in a method that we've already defined. How that method works, we have a really good blog post about that, because what is fairness and what is balancing? You could argue, depending on the use case, it's different. So I'm not going to go, that would lead me too deep for this session. But if you go on our website, on the blog, you will find what is fairness, and that will talk about balancing. Okay, good. There was another question here, or? The microphone? Yeah.
Yeah, hi. So is it possible to have hard constraint that we can't have a solution?
Yeah, so Timefold will give you the best solution it can find in the time you've given it.
Even though it violates the hard constraint?
Yeah, even though it still has a hard constraint. It could be that what you're asking is just not possible. Now, what we see with some of the other solvers in this space is that they will just say there's no feasible solution in the end. What you will get with Timefold is, even if you have a hard constraint, you will get the explanation why. And then it's up to the business to decide what they want to do with that. Is it really, if it's a nurse trying to do heart surgery, you can't accept that. But in some other cases, you might say, it's okay, or it can also inform hiring decisions or more strategic decisions for a company. If they try to make a schedule and each time it has a hard constraint of someone that needs to do heart surgery, yeah, then maybe you need to find another heart surgeon or not accept as many heart surgeon customers, you know? So that's what you should know is that I work for the company that backs this open source. So the open source is free. We have some stuff around that. And I joined 6 months ago because I'm excited about this kind of stuff. Like we can, this Timefold thing can give you an answer even if there's no good answer. And it can explain to you why it's the best answer we found, but it's not a good thing yet. But hey, it's the best we could find. So that's it. And any other questions, by the way? Yes, one more?
Just quickly.
Yeah.
You didn't really highlight it, in what sense this is an AI. I mean, you don't train it, it doesn't learn. So are these very clever algorithms? I don't really understand the difference. You know, when is it AI, when is it just very well-written algorithms?
So I will continue with my slides, because I think I will get to that in a bit, if that's okay. Okay. So with Timefold, what you need to do is basically you model your domain in Java code. I think most of us are Java developers, so you know a bit how to model it in Java code. You add some annotations, you write these constraints, and then you basically run it, and then you get an answer back. So there's quite a bit more use cases than employee scheduling. There's vehicle routing, so that actually, like I said, a bunch of vehicles, a bunch of packages, and you drive them around. Maintenance scheduling, order picking, conference scheduling. So I know that quite a few conferences are actually using Timefold to schedule the rooms, because scheduling speakers and such is also difficult. When are speakers available? The stars you gave probably in the app to say what sessions you wanted, that actually influences what rooms get assigned to which speakers. So all these kind of constraints, I believe the conference scheduling one has 40 constraints or something. So a bunch of interesting stuff. Also and personally, I have a teacher's degree, and I remember people at school struggling to make a school timetable because same problem. If you have chemistry, you need a chemistry room. How are you going to divide all the lessons? Make sure that if teachers give multiple subjects, that they're scheduled correctly. We also have an example for that you could just check out and try and see if you can. It would actually bring me a lot of joy if some of you took some of these and tried to employ them somewhere, because that will make the world quite a bit better. So does this sort of optimization matter? I'm giving you one concrete example of one of our customers. Vehicle routing. So a bunch of different cars, a bunch of packages, how do you divide them correctly? And that specific customer was expecting, maybe if they already had some sort of planning, probably when I optimize it, it will be like 1% driving time. And 1% driving time, when we're talking about millions and millions of packages a year, is a lot of money. It was 25, which meant about, in this case, 100 million kilograms of CO2 emissions last year. So if you're ecologically inclined, this optimization, pretty cool. If you're more monetary inclined, see, it also saves a bunch of money. I'm personally more on the ecology side, but whatever works. So I said LLMs can't optimize schedules, but AI can. But then what is the future? What is the future? And this is where we come to the AI and GenAI discussion. Because your question was, why is this AI and not just fancy algorithms? So historically, when we taught AI, the first forms of AI was basically a sort of Pong. Remember Pong, the two bars? People found it magical that the other bar was able to block your ball sometimes, and that it was like playing with you. That was considered AI. Then we thought, no, that's too simple. That's too simple an algorithm. It's not AI. Then we have more advanced algorithms, like Timefold that I've shown you today. And then we said, yeah, but it doesn't learn anything. That's not AI. So then we read machine learning. And then after a while, we said, yeah, but they're not creative. That's not AI. So now we're at GenAI. And you can already feel the first things, like we're starting to understand GenAI a bit more. Now people are saying, yeah, but it's just generating the next token. That's not intelligent. So we keep moving the goalpost of what AI actually means, and you'll see that it is moving further and further away. So when you ask me, is this not just advanced algorithms? Sure, it's just advanced algorithms. But in the academical space, these kind of algorithms are still considered AI. And that's kind of why I'm saying LLMs can't solve these kind of problems, but AI can. And if you take anything away from today, I want you to remember that GenAI is only a very small part that now gets so much attention, but there's cool other technologies like machine learning and mathematical optimization that I showed you today to solve really big problems. So, yes, I consider it AI. That's a long-winded answer. But the cool thing for me is, if we could not only go like, oh yeah, but that's AI, that's not AI, what if we could integrate all these things together? Then we get something really powerful. And of course, the baseline is, yeah, if this is just Java code, then let's let the LLMs write this Java code. Like, let the LLMs do all the constraint streams and so on. Now, we are actively testing and trying to help the community, like, what LLM should you pick to write the Timefold code? So far, not very successful, but we do have our own GPT now. Has anyone seen a GPT, like how you make a custom one? Let me just open this one. I'm just quickly going to show you, right? So up. So this is our Timefold GPT. Let's go. Yes? So, oh, come on. So you can edit this. Oh, come on. Don't work against me. Oh, so nice, I handed out cookies, come on. Yes, edit GPT. So you can create your own custom GPT and you can give it all sorts of instructions. So, come on. Yes. Oh, it is, my screen is completely freaking out. I think this is, I think I didn't feed my machine enough coffee this morning. So you can give it all sorts of constraints. Yeah, that's not just freaking out. Anyway, so what we did, I'll just explain it to you. We gave it some important things, like always respond in a witty and approachable way, because we find that important. And then I basically generated the entire documentation in PDF and gave it to it. And now it's giving much better responses. So this is one of the things that we are actively experimenting with. I see that I don't have time to actually show you this in detail. Another thing that we've been doing and experimenting with these LLMs is integrating it with something like the Model Context Protocol. If you haven't heard about that before, it allows you to connect deterministic Java code or whatever to LLMs. And let me show you one example of that. Let me just open Goose. Does anyone know about Goose? So Goose is basically just a desktop app that allows you to connect any LLM to it. And I'm connecting to Qwen 2.5, which is a local LLM. So nothing of this is going on the internet. And I actually have connected an MCP server to it that exposes a compiler to the LLM. So I might be causing like some AI apocalypse where I'm giving a compiler to an LLM, but let me show you what that kind of looks like. So public class hello, and then of course I need to write public static void main string args up. Oh yes, typing without ID is so much better. Print line, hi. And now it will connect to an LLM that's running locally. And after a while, if Goose wakes up, so this is not super fast like the paid ones, there's a reason why you should pay. See, it's asking me, will you allow me to call a tool? So that's an MCP server that I installed locally. I have an entire blog post that I will share in the links afterwards as well. And then it's trying to call this tool with basically this string. So I will allow the tool. It calls the extra server I gave it. Now, the cool thing about Goose is you can actually ask it to either do it, you can tell it to go automatically, so then it doesn't ask approval. But personally, I'm afraid of that. So I ask it to give me to ask for manual approval each time. So it is running. Oh. I thought I already approved it. Oh yeah, so I get the answer, class hello is public, should be declared in a file. So you can see that this is actually the answer of the compiler that I then gave back to the LLM. So these kind of integrations really fascinate me deeply. It's finding out where we can combine LLMs and other sorts of technology. So in this case, it was just a Java compiler. MCP, kind of discussed that. So the key takeaway here is that I think that we can integrate a bunch of these old algorithms / AI with the newer things and make the world quite a bit better. Because these all have different strengths. GenAI is very good at data extraction and explaining things. Machine learning is good at prediction. Maybe something else we might need when we're making schedules to predict how many nurses we need. And planning AI, something like Timefold, is very good at scheduling. Cool thing is we can do all of this in Java, and there's actually, spoiler alert, a workshop that I'm going to put online soon. That's AI, not just GenAI with Java, that will integrate these things into a cool little workshop. So that's coming soon. To conclude, I think GenAI is awesome, right? Cat pictures, anything you want. There's a bunch of good things that it does, but it can't do everything. And I think that sometimes in the hype bubble, we forget that it can't do everything. And we need to be aware of that. I think that having a good eye on what other things are out there will benefit us greatly. And I want you to, whenever someone says, I did something with AI, really think, which one of these layers are you talking about? Because mainly they're talking about GenAI. And I'm really trying to push friends and colleagues to say GenAI when they use ChatGPT and not AI, because AI is so much more than that. So that was my talk for today. I'll be hanging out for quite a bit more. That's a QR code to all the resources. And if you have any feedback or things that I can do to improve this talk, do let me know through the DevBox UK app. So thank you very much.